Okay, so these are the solutions to the problems about testing a claim about a mean using a confidence interval. Um, so number one for the first situation, um, the average number of runs scored by a Major League Baseball team is 4.17 runs per game. So this is an equivalence statement. All of the ones on this are going to be an equivalence statement because we're using a confidence interval. So the equivalent statement is that the mean is 4.17. The alternate hypothesis would be that it's not 4.17. All right. All of these problems are going to be two-tailed because they're equivalent statements, which means that this part is a not equal. All right. So the third part is where we have to reach for the calculator. So let me get that out. Okay, so remember that when you're making a statement about a mean, given the data, we're going to use a t interval. We're going to go to the statistics. The mean that the data gave us in this first scenario was 3.62, and the data had a standard deviation of 2.73. The number in the sample was 34. We're calculating a 95% confidence interval. And there's my interval. It goes from 2.6675 to 4.5725. So let me transfer that back to the sheet. All right, so the calculator gave me the interval 2.6675 out to 4.5725, right? So on that interval, 4.17 happens to be on that interval, so we fail to reject the null hypothesis. And why do we do that? Because 2.6675 is less than the 4.17, which is less than the 4.5725. All right, so we're going to fail to reject that. In all of these problems, the null is going to represent the claim. So we can say that the data supports the claim that the average number of runs scored by an MLB team per game is 4.17. All right, so the data does in fact support the claim. Let's move on to the next situation. Okay, in the second problem, we've got that American workers claim that on average that they work on average 50 hours per week. All right, so again, this is an equivalence statement that the average either is 50 or that the average is not 50. Okay. Because it's an equivalence statement, this is always going to be a two-tailed test. All right, so now we got to get the confidence interval given the data, so let's get the calculator out for that. All right, so let's throw the data for the problem into the calculator. We're going to take stat tests. We're going to do a t interval. The mean in the problem is that they have 44 hours with a standard deviation of 2.3. The number of workers is 200. It's a 95% interval. So this is giving me 43.679 to 44.321. So let's transfer that over to the paper. All right, so we just got the interval 43.679 to the maximum 44.321. 50 is not on that interval, so we reject the null hypothesis because 50 is not on interval. Number 5, the data. So remember, in each of these problems, the null hypothesis is the claim, so the data does not support the claim that American workers work an average of 50 hours per week. All right, so that's the second situation. Let's look at the third one. All right, so the third one is that I claim that I stopped my class 9 times per class period to redirect students. Let's see how that works out. So my claim is that on average I stop 9 times. The alternate to that would be that I do not stop 9 times, right? Again, all of these problems are two-tailed test problems because they're all going to be equivalent statements with a not equal. So let's look at the data and use the calculator to see what that gives us. Okay, again, each of these problems requires a t-test, or t-interval rather. So in this problem, the mean in the data is 7.5 with a standard deviation of 3.1. We've done this over a period of 45 class periods. So when we calculate the interval, we get 6.5687 to 8.4313. All right, so let's transfer that over to the paper and start drawing some conclusions. All right, so let's look at that interval. The interval is 6.5687 to 8.4313. 9 is clearly not on that interval, so we reject the null hypothesis. 9 is not on interval. And number 5, we get to draw the conclusion that the data does not support the claim that Mr. Beam stops 9 times per period. Okay, looking at the fourth problem. The average tenure of a head of school at Garrison Forest is 8 years, so that's an equivalent statement. The null hypothesis is that the average is 8. The alternate hypothesis is that the average is not 8. Again, all of these are two-tail tests. So now we go to the calculator to look at how does the data line up with the claim. Okay, so we go turn it on. Then we go stat tests, looking at the t-interval. There it is. The mean from the data is actually 12.64. Excuse me, with a standard deviation of 11.13. The sample size here is 11. All right, so we calculate the interval and we get 5.1628 to 20.117. It's a huge interval, and that's in part because my sample size is really, really small. All right, so let's transfer that number over and see how well that works against our claim. All right, so this interval that we got here was 5.1628 to 20.117. We failed to reject H null because 1628 is on that interval. So in the end, we say that the data supports the claim that the average tenure of a GFS head is 8 years. All right, so there's the solutions for all of the mean problems with intervals. If you have questions, please email or do one of the drop-ins, or we go from there. Hope you're all well. Thank you.